All right, I'm going to run through the second review packet really quickly today because I kind of want to get it done with, but I want you guys to be prepared for your test tomorrow. So we're going to start with the simple ones, 1 and 2. It says if the perimeter of a rectangle is 26 centimeters and one side is 5, find the area. So I'm going to do my work down here. If they don't give you a picture, you should draw one. So there's my rectangle, and I'm just going to say that side's 5. All right. Now, if I know the perimeter is 26, I'm taking up 10 of that already, so I'm left with 16. 16 centimeters left to divvy up between my other two sides, so that must mean each one of these is 8. Last step, the area of a rectangle is base times height. My base is 8, my height is 5, so my area is 40 centimeters squared. 8. Number 2 is trying to trick you, really. It says find the area of a parallelogram to the right. Well, many of you are going to think, oh, 5 is my base. Well, don't think that, because you always want to look for a perpendicular. There's my perpendicular, which means that has to be my height, and 3 has to be my base. So my area is going to be, oops, I'm getting out of myself. My area is going to be 6 times 3, which gives me 18 centimeters squared. All right. Numbers 3 and 4 are coming up. We've done a lot like number 3, so you can guess that's probably going to be something like number 3 or like the other ones that have been on yours with parallelograms and trapezoids. All right. So if we're looking at number 3, many of you are going to go, oh, my base is 10, my height is h. So if I want to set the area up, it's going to be area equals, don't forget the area of a triangle is 1/2 base times height, so it's going to be 1/2 10 times h. That doesn't get me very far because I don't know what a is, I don't know what h is. So then I look, well, I also have this perpendicular right here. That must mean there's another base and a height. And look, I have both of them. So I'm going to find the area using that 1/2 15 times 3. And I get my area to be, I think, 22.5. I think. Let me just check. Again, I forgot my calculator. Let's see. Stuck. All right, so we do get 22.5, so I'm going to go over here. I now know my area is 22.5. Half of 10 is 5, so I end up with 22.5 equals 5h. I'm going to divide by 5. My final height is 4.5 centimeters. And you can always check and go 4.5 times 4.5 times 10 gives me the same area that I got before, so I must have done something right. All right, number 4 says find the area of if the area of the trapezoid is 95 centimeters. So erase that green line. Find the value for h. So I would go to my formula sheet, or remember this, hopefully. That's 1/2 h base 1 plus base 2. So I know the area is 95. I don't know h, but I know my base 1 is 6 and my base 2 is 14. Again, it doesn't matter which one you call base 1 and base 2. They're just going to get added together. So I'm down to 95 equals 1/2 h times 20. 95 equals 10h, so I'm going to get h to equal 9.5. And don't forget your units, which are centimeters. All right, moving on to number 5 and 6. 5 is a good one because I know a lot of people tend to struggle with kites, but all you really have to do is look to your formula and find that the area of the kite is d1, d2, and I've got a lot of questions of what's d1 and what's d2. That just stands for diagonal 1 and diagonal 2. So I'm just going to call this one diagonal 1. So that whole diagonal is 6. And I'll call this one diagonal 2. It doesn't matter. Again, they're just going to get multiplied. That whole diagonal is 9 plus 4, which is 13. I multiply that out, and I should get 39 centimeters squared. So that one's really not that tough if you know the formula for a kite. Number 6, though, you can do this 2 ways. You can look at my work down there. We'll go through that method. But I know that a lot of your inclination is going to be, okay, I need to find the height. So just looking at this blue triangle here, it is now a right triangle. I know the angle is 60.6. Trying to find the opposite side, which is h, and I know the hypotenuse, so my trig ratio is going to be sine. So I'm going to do sine of 60.6 equals h over 2.6. Cross multiply, I get h equals, let's see, sine of, oh man, sorry, I gotta get my calculator in the right mode. Sine of 60.6 times 2.6 gives me a height of 2.27, let's say. All right, so I now know my height is 2.27. So I go to the area formula, which is base times height. My base is 4.1, and my height is 2.27. I get an area of 9.3 centimeters. Oh, I didn't tell you this is centimeters, so we're just gonna call it units squared. Right, but there is one way that we learned earlier, and we learned the formula that found the area of triangles. So I'm going to erase the work I have over here for now. And I'm going to divide this parallelogram into two triangles. So I'm just looking at this triangle. We learned that a formula to find the area of a triangle is 1/2 AB sine of C. And to do this, I need a triangle that has side, angle, side. So I need two sides with an angle between them. I have 4.1 side, angle, and side. So my A and B in this formula are the side lengths. So 4.1 times 2.6 times the sine of 60.6. And let's calculate that to see what we get. Uh-oh. I get 4.64. So that means the area of this triangle is 4.64. And I have two of those, so I'm going to multiply by 2. And I get a total area of 9.29, which is virtually the same as 9.3, so we're not too far off. Number 7, 8, and 9. Number 7 is just like number 6. So if I look at number 7, again, there's two methods. I can draw in my height. That's the opposite. This is the hypotenuse. A couple people's inclination to say, oh, I know the adjacent's 5.7, but do realize that the 5.7 goes all the way to that point. So that does not work for us. All right, so I know my opposite and I know my hypotenuse. So I could find the height using sine. Sine of 38 equals h over 5.1. So my height is going to be 3.14. Now I can use that height in my base to find the area. And don't forget the triangle is 1/2 base times height. So I get my final area to be 8.95. And I didn't give you anything, so we can just write units squared. All right. Now again, we can use that same formula we did last time though, so I'm going to erase what I have over here. To use that formula, I need side, angle, side. So I could just do 1/2 5.7 times 5.1 times, sine of 38. And I should hope that that gives me the same thing. And then I get 8.95 again. All right, so now we're getting to some circles. I'm going to move these answers down because we can look those up. So number 8 and 9 were the ones I had a couple questions on in class. And again, I always go back to the formula. So it says we have a circumference of 9 pi. So I'm going to start with, circumference is 2 pi r. In this case, I know my circumference is 9 pi. So I'm going to fill that in. Now I need to solve for r, so I divide by 2 pi. So the pi's cancel out, so I'm in the end, I'm just doing really 9 divided 2, so my radius is 4.5. Now that's all fine and dandy, but don't forget to go back and say, oh, it asked me to find the area. So I have to do pi r squared, which is 4.5 squared. And I should get my final area to be 20.25 pi centimeters squared. Now, if it tells you to leave your answer in terms of pi, that is what your answer should be. If you wanted to, though, in this case, it doesn't tell you that. You can multiply out the pi and get an answer of 63.56. Either of those will work. Okay. Number 9 is the same exact problem, but the only issue is instead of having 9 pi, I have a circumference of 10. So 10 is now equal to 2 pi r. And I'm still going to divide by 2 pi. Right, so my 2 pi's cancel out over here, so I'm left with r equals. Now, if you're going to type this into your calculator all at once, notice there isn't any pi to cancel the 2 pi. So I actually have to type 10 divided by parentheses 2 times pi, parentheses. And I get my radius to be 1.59. Again, go back and see it asked me to find the area. So my area is going to be 1.59 squared pi. And I'm just going to go ahead and multiply by 3.14 and get an area of 7.95 centimeters squared. So the slight difference between number 8 and number 9 is that my pi's cancel in number 8, so I'm left with a nice number, sort of, for a radius. This one, in number 9, I actually have to divide out the pi, so it's not going to be quite as nice of a number. I'm going to move on to number 10. Number 10 is a great problem because it really gets you thinking about how do I find the area of a hexagon? And I'm going to do that by just looking at the triangles that make up this hexagon. Because it asked me to find the shaded region. Notice I have 4 triangles that are shaded. I'm solely going to be looking at this first one. And red's probably not the best color to use. All right, I'm solely going to be looking at this first one. I know the base is 2.3. In order to find the area of just that triangle, I need to find, that's terrible. I need to find the height. So I have a right triangle happening there, and I'm going to draw it bigger over here. If I can draw today, oof. So that's really that right triangle that I'm looking at. And since the whole thing is 2.3, this is going to be 1.15. I'm trying to find this height. We can also label it as h if we want to call it the apothem of that. Now my goal is to find either this top angle or this side angle. Lots of people find this top angle. So the way you're going to do that is you're going to go, okay, this whole thing has to add to 360 degrees. And I have, if I were to look at the triangles, there's 6 triangles that make that up. That gives me 60 degrees. That would be the whole angle. So this height is going to be 30 degrees. Now I can use that angle because I know the opposite side. And I'm trying to find the adjacent side. So I'm going to use tan. So tan of 30 equals 1.15 over A. Cross multiply. I get A times tan of 30 equals 1.15. And divide by the tan of 30. I get 1.99 for my apothem. Not squared, excuse me. So I go back up to my picture. I now know this is 1.99. So to find the area of just that one triangle, I'm going to do 1/2 2.3 times 1.99, which equals 2.29. That's just the one triangle, and I have 4 of them, so I need to multiply that by 4. I get 9.15 for my whole thing. Right? I guess it's in units. We'll just call it centimeters. So I get 9.15 for this whole thing. Because I have one triangle that's 2.29, and I have, again, 4 triangles that are shaded. And we're moving on to number 11. I'm not sure when the second page started. I think this is the last one on the second page, so I'll stop and make a new video after this one. So number 11 it says find the area of the shaded region. So first step is we need to find that angle in the shaded region. So I'm going to do 360 minus 90, and that leaves me with 270 degrees. So when I set this up, I'm going to do 270, which is the shaded part, out of the whole circle's angle, which has to be 360, equals the area of the shaded part, which I don't know what it is, so I'm going to call it x, over the area of the whole circle. So again, angle of the shaded part over the angle of the whole circle equals area of the shaded part over area of the whole circle. I can find the area of the whole circle because I know the radius is 8. So the area of the circle equals 8 squared pi, which gives me 64 pi. So I'm going to put that down here. To do this, I'm going to cross multiply. I get 360x equals 17,280 pi. I'm going to divide by 360. And let's see what I get. I get 48 pi for the area of the sector, and it's in centimeters squared. All right, so I hope that finishes up page 2 for you on the review. We will start the next one